Bismillahirrahmanirrahim and Assalamualaikum. In this video, we would like to present about the application of geometry in our life. First and foremost, our group consists of 4 members. So the first person is Nur Shifa Hazika binti Muhammad Hazir, and the second person is Nur Alia Nabila binti Abdul Rahman, and the third person Kaisara Afika binti Muhammad Ashraf, and the last person is Nur Nadia Umaira binti Basirin. For the first slide, we have the history of geometry. Beginning about the 6th century, the Greeks gathered and extended this practical knowledge, and from it generalized the abstract subject now known as geometry. From the combination of the Greek words geo, earth, and metron, measure, for the measurement of the earth. In ancient, the Egyptian, the Romans, and the Greek used geometry in the world of architecture. It was used to solve most problems, from building, construction, to astronomy.
Move to another slide. We have another history about netball. The sport of netball is an English invention that traces its roots to basketball. In 1891, an American physical educator, James Naismith, created the court and ball game known as basketball. It was designed for students linked to the Young Men's Christian Association or YMCA. However, at the time, women's dress conventions of ankle-length skirts and wrist-length shirts hindered their physical movements and meant that playing basketball with dribbling and throwing long passes was difficult. So some female educators formed a modified version of the game. Instead of changing the female attire to fit the needs of the basketball rules, they modified the game to fit within the accepted feminine practices. Women's basketball, as netball was originally known, emerged as identifiable sport in the late 1890s when the rules of dribbling were omitted and the inaugural rules for women's basketball were established. Under these rules, the court was divided into 3 zones. The number of players were increased from 5 to 9. A smaller ball was used, and there were 2 umpires, 2 scorers, and 2 timekeepers. The modern game of netball still features 3 zones and 2 umpires, but has 7 players on court. A netball court is 30.5 meter long and 50.25 meter wide. The longer sides are called the sidelines, and the shorter sides the goal lines. The court is divided into 3 equal parts, parallel to the goal lines. Each third measures 10.167 meter wide. The goal circle is a semicircle 4.9 meter in radius, and its center is the midpoint of the goal line. The center circle is 0.9 meter in diameter and is marked in the center of the court. All lines are part of the court and 50 millimeter wide, preferably wide. It is recommended that they are a textured water-based acrylic, straight and have clean, crisp edges.
Based on this history, we have made a question about netball court. So this is a question. The diagram shows the measurement for the netball court. Given the length of AB is equal to 30.5 meter and the length of AF is equal to 15.25 meter. The diameter for the small circle is 0.9 meter and the area of semicircle is 37.73 meter square. The question needs us to use pi equal to 22/7. So the first question is find the radius of semicircle. Since the question give us area of semicircle, so the formula area of semicircle is 1/2 multiplied by pi r square. So what we need to do is just replace the area of the semicircle given and then replace the pi. So 37.73 equal to 1/2 multiplied by 22/7 multiplied by r square. R square are not given, so we need to find the value of r. So 1/2 multiplied by 22/7 is 11/7. And then we need to multiply 7 by 37.73, and then we get 264.11 equal to 11 r square. So r square is equal to 264.11 divided by 11. R is equal to square root to 24.01, and the answer for r is 4.9 meter. Alright, so that is the radius of the semicircle. Next, the second question is area of shaded region. Find the area of shaded region. Right. Formula area of shaded region is area of court minus area of 2 semicircle and the small circle. So first step is we need to find area of court. So the formula is area of court is length multiplied by width. So 30.5 multiplied by 15.25 is equal to 465.125 meter square. Okay. After that, we need to find the area of these 2 semicircle. Since the question give us the area for one semicircle, we just need to multiply by 2. So 37.73 multiplied by 2, we got 75.46 meter square. Okay, and then last step is we need to find the area of the small circle. The question gives us diameter of the small circle. So what we need to do is we need to find the radius first. So 0.9 divided by 2, the answer is 0.45 meter. So formula of small circle is pi r square. So pi is 22/7 multiplied by 0.45 square, and we got 0.6364 meter square. So we can find area of shaded region now. How? 465.125 minus 75.46 minus 0.6364. The answer is 389.0286 meter square. Okay, that's all for question 2. Now the last question is find the perimeter of shaded region. To find the perimeter of shaded region is AB, summation of AB plus BC plus RCD plus DE plus EF plus FG plus RGH, and the last one plus AH. So what we need to do is, number one is we need to find length of BC. For your information, BC is equal to DE, is equal to AH, and is equal to GF. So how to find BC? We need to find BC by BE minus CD. CD is 4.9 multiplied by 2 because we already got the radius. So CD is the diameter of the semicircle. So to find the CD, we need to multiply by 2. So CD is 9.8 meter. Okay, now we can find BC. 15.25 minus 9.8 divided by 2, and we get 5.45 meter. Okay, now we need to find arc CD and GH. Arc CD equal to arc GH. So how to find arc CD? The formula of arc CD is R theta. R is 4.9 multiplied by pi radian. It is because theta for semicircle is pi radian, and 180 in degree. So 4.9 multiplied by pi radian is 15.3938 meter. Now we can get the perimeter of shaded region, which is 30.5 plus 5.45 plus 15.3938 plus 5.45 plus 30.5 plus 5.45 plus 15.3938 and plus 5.45. So the answer of the perimeter is 113.5876 meter. And that is for our case.
So another case that can be applied in geometry is ice cream. There is a short story about ice cream. So in this slide, we will talk about the history of ice cream. A famous merchant and traveller by the name of Marco Polo returned to Italy from his travels with a recipe that closely resembles modern sherbet. Eventually, in 16th century, the recipe would slowly begin to evolve into ice cream. The difference between sherbet has roughly 2 dairy ingredients, while ice cream is primarily composed of mixture of ice cream, like cream milk and eggs. Ice cream may be served in dishes, eaten with a spoon, or licked from ice cream cones held by the hands.
So in this slide, we will talk about the history of ice cream. The first ice cream cone was produced in 1896 by Italo Marconi. Marconi, who emigrated from Italy in the late 80s, invented his ice cream cone in New York City. He was granted a patent in December 1993. There are so many types of ice cream cone, such as cake cone, wafer cone, sugar cone, and maple cone. This is the question for the second case. Diagram 2.0 shows an ice cream cone. As we can see, the shape of ice cream is hemisphere and cone, given that the slant is 5 cm and the height of the cone is 4 cm. Find the surface area of cone. The formula of surface area of cone is S by R. So this given S and R, S and pi. So we have to find R. Find R by Pythagorean theorem. So R equal to 5 square minus 4 square. So R equal to 3. So the formula is surface area is 22/7 times 3 times 5. So the answer of surface area of cone is 47/1/7 cm square. The question number 2 is surface area of hemisphere. The formula of surface area of hemisphere is 3 pi r square. So we have to include the given as surface area 3 times 22/7 times 3 square. So the answer is 84/6/7 cm square. And the last question is total surface area of cone and hemisphere. The total surface area
we have to surface area of cone plus surface area of hemisphere. So the answer is 47 1/7 plus 84 6/7, and the answer is 132 cm square.
So for the next question, the picture shows an ice cream cone has 5 inches deep and has a radius of 1 inch. A spherical scoop of ice cream also has a radius of 1 inch. So the question is, if the ice cream melts into the cone, will it overflow? So we know that we have to find volume of cone and sphere. Okay, the formula of volume of cone is V equal to 1/3 times pi times r squared times height. Okay, we know that the radius and the depth of the cone, so we apply it on our formula. So the volume of cone is equal to 1/3 times 22/7 times 1 squared times 5. So the answer is 5/21 inch cubic. So the volume of sphere, the formula is 4/3 times pi times r cubic. So the volume of sphere is 4/3 times 22/7 times 1 cubic. So the answer, we get that 4/21 inch cubic. So the answer is the volume of spherical scoop of ice cream is less than the volume of cone. So there will be no overflow. It is because the ice cream will overflow if the volume of the ice cream, a sphere, is greater than the volume of the cone.
The conclusion that we can make from these two cases is, for the netball court, by solving the first case, we got to apply geometry skills as we learned in Chapter 6 and Chapter 8 in MAT123 subject. For the ice cream, by solving the second case, we got to develop more skills in geometry, which is the surface area and volume of certain food like ice cream, to be used in order to try new recipe if interested to try a business in the future.
Last but not least, there is the conclusion that have been made about application of geometry is, geometry is used in every aspect in our daily life, such as variety of fields, including art, measurement and buildings. Second, geometry provides many foundational skills and contributes to the growth of logical thinking, deductive reasoning, analytical reasoning and problem-solving abilities. And the last one, by learning this application of geometry, we can get a chance to become an architect if we learn more details. This is the reference which we use throughout our project. That's all from us. Thank you.
Got it!